Okay, so this question is asking to factor and solve this polynomial right here. We have x to the fourth minus 2x squared minus 8. Okay, so essentially the way to think about this type of problem is, I'm going to actually rewrite it like so. Okay, so what I did is I just kind of separated out x to the fourth in terms of x squared, the product of x squared and x squared, and then I just included this x squared in parentheses, just to show that, just to emphasize, and actually I'm going to, that there's kind of a base x squared term in both of these, both x to the fourth and negative 2x squared. And I'm actually going to rewrite it one more time. Like so. So you can see here, there's kind of this base x squared term contained within the first two terms of this expression. When you identify a pattern like that, then that's a signal to go into, to use what's called U substitution method. As the name implies, we're actually going to, because we can't factor this using the trinomial method, this is kind of an intermediate step between the expression written as is and then the actual factored form with the trinomial method. We use U as an intermediate substitute. So in this case, we'll actually set U equal to that base term, which is x squared in this case. And I can actually further write it like as U squared is equal to x to the fourth. Okay, so when I write it like that, now I can actually just write this expression in terms of U, where I'll end up with a U squared in the first term. So this will be equal to U squared minus 2. This is just going to be U, right? And that's also U, but this is the U squared. So this will be U squared minus 2U, and then minus 8. The 8 is just remainder. And that constant is going to be kept in both expressions because we're going to be using the trinomial factoring method. So now that we have that written, you can see this just becomes a method used. Now we can just use trinomial method. So except with x, we just have the expression in terms of U, which isn't a problem. So that will be, this is what the expression will be equal to when we actually factor it using trinomial method, the same trinomial method we've done in many other problems. But all we have to do now is, because we want to actually factor it in terms of x, because the original problem is given in terms of x, we're just going to reverse substitute that U for x squared. Anytime we see a U, we'll put in x squared instead. So this will be equal to x squared minus 4, and then x squared plus 2. As you know, x squared plus 2 cannot be further factored due to the plus sign. So, but because of the perfect square method, this can be factored into quantity x minus 2 times quantity x plus 2. So then with the remaining unfactorable x squared plus 2, that's going to be our actual fully factored form of the original expression. And so we factored, that was the factoring part, and we have to solve to find the solutions to x. We're going to assume this is equal to 0, and then we'll say that x is, the real number solutions will be negative 2 and 2 from here, from this expression and that expression. And then to find this expression, the answer as a review, we'll just take the square root of that -2. We'll take the square root of both sides, x squared and the -2. So this will be equal to plus or minus negative radical 1 times radical 2. I'm not going to do the plus or minus quite yet, actually. And then to simplify that, so we know by definition the radical of -1 is equal to I, which is just an imaginary number. So this will be equal to the, I mean, you can call it plus or minus I. So this will be equal to plus or minus I radical 2, or I times, plus or minus I times radical 2. So to add to the final solutions, it'll be plus or minus I radical 2. And that is our answer. In terms of our solution and our factored. And actually so this is our solution. And then this is going to be our factored form or factored expression.